So question 8 says for the polynomial function below, list each real zero and its multiplicity. Then part B, determine whether the graph crosses or touches the x-axis at each x-intercept. Determine the maximum number of turning points on the graph, and then determine the end behavior, that is, and then find the power function that the graph of f resembles for large values of absolute value of x here. So that should be like absolute value of x. So to find the zeros, notice it's in factored form. So all we got to do is set the factors equal to 0. Notice how the negatives, well, I can just set the whole thing to equal to 0, I should say. -7 times x minus 7 times x plus 9 squared is equal to 0. Notice it's already factored. Notice that I can divide the -7 out. So all I really got to do is set these two to 0. So I have x minus 7 is equal to 0. Notice I have this x plus 9 twice. Since it's a power 2, that means there's 2 of those present. So if I solve those for x, I have x equals 7. I have x equals -9. But notice how it occurs twice. Since it occurs twice, we call that a multiplicity of 2. So I'm going to abbreviate multiplicity of 2, since there's 2 of them. Notice the 7 only occurred once, so this really only has a multiplicity of 1. So the zeros are the 7 and the -9 are the zeros. So the multiplicity of the larger zero, since 7 is the larger zero, it's going to have a multiplicity of 1. The multiplicity of the smaller zero, which is the -9, it's going to have a multiplicity of 2. Now, one of the things we pick up on is this. When it comes to graph behavior, a multiplicity of 1, what's going to happen is it's going to cross the x-axis. So there's going to be a sign change in the y values. If there's a multiplicity of 2, what's going to happen is the graph is actually going to touch. So it touches and it kind of turns back down. So it's going to kind of make, like, remember how degree 2 kind of makes a curve, a max or a min, if you will. So that's kind of what's going to be happening here. So if I look at this function up here, y equals, if I clear this all off, I'll put that -7 in, parenthesis x minus 7, and then in parentheses x plus 9 squared. If I graph this, notice I don't see a whole lot of graph. I really need to change my viewing window a little bit. So I'm going to change my y scale a little bit. So let's change this to a -100 and the y max to 100. And let's just go by 10s and see if that helps us any with the viewing window. Not much. It really takes off quite a bit. So I do see a little bit more here and here, but let's try one more time on the y max. Let's say 1,000. If I do that, let's make this go by hundreds. And see, we get a little bit more. It's still way up there. We'll go one more time. Window, let's say 10,000. Let's go by 1,000. And graph again. Now we can kind of see the graph really kind of flatten out for us there. So if I want to see a little bit more of this over here, I can kind of tweak that a little bit. But you can kind of see this graph has a couple things going on here. Let's go a little bit more left. So if I go to the window, let's make this like a -20 over here. And let's just go by 5s. See how hard it is to get this thing to work. Okay, and so now you can kind of see, and if I want a little bit more below, if I go to window, if I want to change my y min to be like, a -1,000, and that shouldn't change it a whole lot. Hit the graph. You can kind of see a little bit more of of what's going on here. So notice that this is a, if you count the zeros and the multiplicities, there's a 1 plus 2 tells me that this is a degree 3. We know a degree 3 typically would run this way here. But notice how the coefficient out front is negative. Since the coefficient out front is negative, that's going to make the end behavior kind of switch over, where the graph now actually is going to finish up and then finish down. So some things we're picking up on is a degree 3 actually can have more turns than what we have here. It can actually turn, that's actually turned twice. So notice that when it comes down, it actually touches and turns at the -9. That's what we're talking about here with the multiplicity of 2. That multiplicity of 2 tells me that the graph actually is going up. So, well, they're actually talking about the multiplicity of 1 first here, the larger one. Notice that the larger one is actually the 7. Notice that the 7 actually just crosses the x-axis. But at the smaller x-intercept, it actually comes down and touches and turns again. So that's what happens at multiplicity of 2s, is it touches. So those are some things that we should be picking up on. Is one is a degree 3 is kind of a snake-looking graph. But since the leading coefficient is a negative, it's going to reflect it over the x-axis. It's going to flip it that way. So the maximum number of turning points is always going to be n minus 1. So since our degree was 3, we have 3 minus 1 is going to be 2. So there can be a maximum number of turning points of 2. Notice that our graph does turn twice in the graph. But I can actually determine the maximum number of points without graphing it by using the formula n minus 1. So whatever the degree is, if I go 1 less than that, that's going to tell me the maximum number of turning points. Now, the type of power function is going to be the leading coefficient and the degree, which is 3. So the power function is actually going to be this -7x cubed, since it's a degree 3. So we need the leading coefficient and that. And what this tells me is the end behavior. So this -7 tells me that this graph is going to have this type of behavior over here, and it's going to look like a third degree function on the outer edges. So as we keep going here, determine whether the graph could be a polynomial. Now, this is question 10. So let me see here. Do we need anything else on this one? So question 8. So A, list B, determine the whether graph, determine the maximum number of turning points, determine the end behavior, that is, find the power function. Okay. So that's all they want us to do there on that one is do that. So again, to find the zeros, we have it in factor form already. So notice that once you have this x minus 7 here, we know it's just the opposite. 7 is going to be its 0. Notice how that there's a +9, which means it's going to be a -9. And notice that there's a power of 2 there. That means it's going to have a multiplicity of 2. And also remember that a multiplicity of 1, the pattern is it's going to actually cross the x-axis. It's going to cross the x-intercept. And if it has a multiplicity of 2, it's actually going to turn at that x-intercept. So that kind of gives us the gist of where we're going with some of this.